Now we will see the applications of operational amplifier. Okay, so we have seen many applications of operational amplifier. Now we will see another application of operational amplifier as an integrated circuit. So this operational amplifier can be used to make an integrated circuit. Okay, so this is the circuit diagram of integrated circuit by using operational amplifier. This is the operational amplifier. So if we are using this R and this capacitor C, now it becomes an integrated circuit. So we will see the expression for V out for this integrated circuit. Okay, now suppose this is IR and this current is IC, and due to virtual ground concept, this is like this. Okay, this is at virtual ground. Okay, see, the internal resistance of this operational amplifier is infinite. R in, it is infinite. If we are considering this operational amplifier as an ideal operational amplifier, then in that case the internal resistance of this operational amplifier is infinite. Okay, and this is connected to ground. So by using virtual ground concept, we can say that IR, it is equal to IC. Okay, IR will be equal to IC, since the current across this, it will be 0 because Rn is infinite in ideal case. Okay, so and what is IR? IR we can get it like this: V in T divided by R. This is equal to IR and this is equal to IC. So our main motive is to determine V out. Okay, so how we can determine V out? V out, it is equal to minus VCT. And how we can determine VCT? VCT, it is equal to VC at 0, t is equal to 0, plus 1 by C integral of 0 to t IC dt by using this expression. So we can write VCT, it is equal to VC naught plus 1 by C integral of 0 to t IC dt. Okay, now just now we have seen IC, the expression for IC, it is equal to IR and it is equal to V in T divided by R. Okay, so VCT, it is equal to VC at t is equal to 0 plus 1 by C integral of 0 to t V in T divided by R dt. Okay, now if VC at t is equal to 0, it is equal to 0 volt. What is this VC at t is equal to 0? If at t is equal to 0 means before giving the input, if voltage across this capacitor it is equal to 0 volt before giving this input, then we can write VCT, it is equal to 1 by RC integral of 0 to t V in T dt. We can write like this: if VC at t is equal to 0, it is equal to 0 volt, means before giving this input voltage V in T is equal to 0, VC0, if it is equal to 0 volt, then we can write VCT, it is equal to 1 by RC integral of 0 to t V in T dt. Okay, Now we have just seen how we can determine V out T. It is equal to minus VCT. Okay, and we are getting VCT. It is equal to this. So we can write it is equal to minus 1 by RC integral of 0 to T V in T dt. Okay, so V output it is equal to minus 1 by RC integral of 0 to T V in T dt. We can write down the expression for output of this integrator circuit. So V output, that we are getting V output across at this point, V output T it is equal to minus 1 by RC integral of 0 to T V in T dt. So what is this RC? RC is the time constant of this RC circuit, and this is integral of 0 to T V in T dt. So we are getting V output, it is equal to minus 1 by RC multiplied with the integration of the input. This is V in T, integration of the input. Thus we can say that this circuit is an integrator circuit, and it can be made by using this operational amplifier and this R and C. Okay, now we will see the integrator circuit having many inputs. Suppose this is V out T, and say this is R1 and this is V in 1 T. This is R2 and this is again V in 2T, and say this is resistor R3 and this is V in T, and it is connected to ground. Okay. So for this integrated circuit, how we can determine V out? So V output can be determined by using superposition theorem. So in superposition theorem, first of all we have to consider V in only, and we do not have to consider V in 2 and V in 3. Then we have to consider only V in 2, and then we have to consider only V in 3T. Okay. So V output it is equal to, in this case it is equal to negative of minus 1 by R1C integral of 0 to T V in 1 T dt plus minus 1 by R2C integral of 0 to T V in 2 dt, then plus minus 1 by R3C integral of 0 to T V in 3 T dt, V into T dt. Okay. So V output T it is equal to minus of 1 by R1C integral of 0 to T V in 1 T dt plus 1 by R2C integral of 0 to T V in 2 T dt plus 1 by R3C integral of 0 to T V in 3 T dt, like this. Okay. So this is the expression of V output T for this integrator circuit having multiple inputs, V in 1T, V in 2T and V in 3T. So here we are using superposition theorem to determine V output. Okay, so in this way we can determine the output of an integrator circuit, and we can make an integrator circuit by using this operational amplifier. Okay, and what is RC? RC is the time constant of R and C circuit. Okay, so this is all about making integrator circuit by using operational amplifier. Then we will see about differentiator. Differentiator circuit. So again we can use operational amplifier in designing a differentiator circuit. So the circuit diagram for a differentiator circuit by using operational amplifier is like this. So this is the circuit diagram of a differentiator circuit by using operational amplifier. Okay, so again by using virtual ground concept we can see that IC it is equal to IR. And what is IC? How we can get IC? IC it is equal to C dV in T divided by dt. And how we can express IR? It is equal to minus V out T divided by R. And by using virtual ground concept we can say that IC it is equal to IR. So IC is equal to IR. And what is IC? IC it is equal to C dV in T by dt, and IR it is equal to minus V out T by R. So from this we can write V out T it is equal to minus RC d by dt of V in T. Okay, so this is the expression for V output of this differentiator circuit. So in this equation we can see that V output T it is equal to minus RC into differentiation of input, that is V in T. Okay, that is why it is known as a differentiator circuit, because the output it is equal to minus this RC is the time constant of RC circuit, and it is differentiation of the input d by dt of V in T. That is why it is known as a differentiator circuit. Okay, now we will see some example. Okay, so how we can determine V output of this circuit. Okay, this is an inverting operational amplifier in closed loop. Okay, so here VA it is equal to 0.2 volt, VB is equal to minus 0.5 volt, and VC is equal to 0.8 volt. And similarly R1, R2 and R3 these are given, and this is RF. RF is given as 66 kilo ohm. So we can determine V output by using superposition theorem. Okay, so we can write it is equal to minus RF by R1 into VA. First is VA, and we are neglecting these voltage. Then again plus minus RF by R2 into VB. Then again minus RF by R3 into VC, like this. Okay, so again this is by using superposition theorem. Okay, so here RF is given, RF is 66 kilo ohm, and this is R1 and this is R2 and this is R3. Okay, so by using superposition theorem we can determine V out. Okay, so it is minus 66 kilo ohm divided by R1 is 33 kilo ohm multiplied with VA is 0.2 volt, then plus again minus 66 kilo ohm divided by R2 is 22 kilo ohm multiplied with VB is minus 0.5 volt plus minus 66 kilo ohm divided by 11 kilo ohm multiplied with VC is 0.8 volt. Okay, so finally we will get V output it is equal to minus 3.7 volt. If we will solve this, then V output it is equal to minus 3.7 volt. Okay, so in this way we can determine the V output for this circuit. Now we will see another example based on operational amplifier. So for this circuit we have to determine V out. Okay, so how we can determine V out? Okay, so we can determine V out again by using superposition theorem. Okay, so first of all we have to determine V output by considering Vx only, and in second case we have to determine V output by considering Vy only. So V output it is equal to V output due to X plus V output due to Y input, and Vox is V output due to X Vx. Okay, and by superposition theorem we can get V output. So how we can determine Vox? Vox it is equal to minus Rf by R1 into Vx. Okay, Rf is 3.9 kilo ohm, R1 is 100 ohm, Vx is minus 3.2 volt. So in this way we can determine Vox. And how we can determine Voy? Voy it is equal to 1 plus Rf by R1 multiplied with this voltage. Suppose this is A, so then we have to write here VA. How we can determine VA? VA it is equal to R3 divided by R2 plus R3 multiplied with Vy. Okay, V at A it is equal to R3 divided by R2 plus R3 multiplied with Vy. Okay, so in this way we can determine the voltage at point A. So Voy it is equal to 1 plus Rf by R1 into Va. So again we have to replace this Va. Va it is equal to R3 divided by R2 plus R3 into Vy. Okay, so how we can get V out? So V output it is equal to minus Rf by R1 into Vx plus 1 plus Rf by R1 into R3 divided by R2 plus R3 into Vy. So in this way we can determine V out. Now here we can see if R1 is equal to R2 and RF is equal to R3. Here R1 is equal to R2 and RF is equal to R3. So if this happens, then we can write this expression. How we can write down this expression? It is R1 plus RF divided by R1 multiplied with R3 divided by R2. R2 is R1, R3 is RF, and this R3 is, again we can replace R3 by RF, okay, multiplied with Vy. So this will be cancelled out, this will be cancelled, okay. So it is equal to RF by R1 multiplied with Vy, okay. So we can replace this with RF by R1 multiplied with Vy. So what will be the expression for V out? Final expression for V out, it is equal to minus RF by R1 multiplied with Vx minus Vy. So we can get here RF is 3.9 kilo ohm, R1 is 100 ohm, Vx is minus 3.2 volt, Vy is minus 3 volt. It is equal to 7.8 volt, okay. So in this way we can determine the V output for this circuit. It is equal to minus RF by R1 into Vx minus Vy. Vx is minus 3.2 volt, Vy is minus 3 volt. So in this way we can get V output, okay. Now we will see this circuit. So for this circuit, how we can determine V output, okay. So here V in 1 and V in 2. V in 1 is 2 volt, V in 2 is 0.1 volt, R1 is 20 kilo ohm, RF is 60 kilo ohm, okay. So we have to determine V output for this circuit. So V output, it is equal to, again by using superposition theorem we can determine V output for this circuit. So it is equal to minus RF by R1 multiplied with V in 1 plus 1 plus RF by R1 multiplied with V in 2, okay. So by using superposition theorem, V output can be determined first by considering this input only, then by considering this input only, then adding it. So this is the output. This is the output by considering V in 1, and this is the output by considering V in 2. Again we are adding it. So this is by using superposition theorem. So RF is 60 kilo ohm, R1 is 20 kilo ohm, V in 1 it is 2 volt plus 1 plus 60 kilo ohm divided by 20 kilo ohm multiplied with V into is 0.1 volt, okay. So finally we are getting this is equal to minus 5.6 volt. So in this way we can determine the V output for this circuit. Okay, thank you.